for 3D technology. So before we start, what is actually 3D? 3D is basically a three-dimensional or a volumetric representation of our usually two-dimensional scans that we have. So today with this technology, we can pre-surgically plan and modify the outcome of the surgeries. With these softwares, the two software that we'll talk about today are specifically designed for surgeons, so they are very user friendly and does not involve engineering complexities. So the first software we'll talk about today is Mimics Imprint. It is this software helps us create 3D models from DICOM files. It helps us give us a file in a STL format, which we can later print in 3D printer. Now the question is, why do we require a 3D model? So we require a model because so that we can easily do surgical planning or mock surgeries on it, and it can also be used for educating the patient or the students about how the surgery is carried out. Then the second software that we'll talk about today will be Proplan CMF. This software is specifically designed for virtual planning of cranio-maxillofacial surgeries. We can plan osteotomies, fibula reconstruction, orthognathic surgeries with this. This helps us analyze and modify post-operative results. We can also superimpose cast scans and create splints that can be later 3D printed with this, with the help of this software. Beginning with Mimics Imprint. First, we'll have to import a DICOM in this. Sorry, just a minute. So in Mimics Imprint, first we'll start with importing a DICOM. For importing a DICOM, when we open, we'll see a window like this, in which we'll go to the file section, and then in the drop-down menu of the file section, we'll have something called New from Disk. From there, we'll click New from Disk, and a window like this will open. And we can browse our file wherever it is in our computer or laptop, and then we click Next. So the next step will be thresholding. Thresholding is used to set our region of interest according to Hounsfield units. So this software has preset thresholdings for bones, soft tissue, and others. Or we can also manually set by this bar. We can move this cursor, this bar with the cursor, and we can manually set or customize our threshold. Keep largest region is used because sometimes it happens that the DICOM images captures the head support that is used in CT scan. So to remove that or other pixels, we just click keep largest portion. So only the selected threshold with the largest portion is selected, and the other images are removed by that procedure. So I'll show how changing threshold will, like manually changing threshold affects. This particular video is of Proplan, but the similar applies to Imprint also. As you can see, please notice the images of DICOM, how the threshold is being changed. So we customize according to our own preferences. The next step is editing the ROI. ROI stands for region of interest. Now that we have selected our region of interest, we can edit it. We can isolate it, split it, and then there is 3D interpolate. Brush and lasso is also used for smoothing and correcting our region of interest. Then we have options of unite and subtract that we'll talk about in the further slides. So first, I'll discuss about split. Split is used to split an area of interest from other areas. Like if we want to work on mandible, so our area of interest is mandible, so we'll split it because in this software, when we upload the DICOM, they all come in single image. So we have to use it as a different bones, so we'll have to split them. So for splitting, we'll have to, like if our area of interest is mandible, so we'll select foreground as mandible. The foreground is the region that is our area of interest. So we'll select mandible, our foreground, and background will be everything else except the mandible. So while this cursor here that you can see is a diameter cursor, we can change the size of the diameter by this cursor. Foreground, when we click foreground, a diameter, a circular diameter circle will appear here, and with that we'll just like pull down, like, or just select these areas with that particular, like we select in Paint or other softwares. We just select this area and it will appear like this. So like this, we have to select it in various DICOM images. We can use this scroll bar that is present on the right hand side of the DICOM image to scroll through various images of the DICOM, and then we can like select it on multiple slices so that our area of interest is like totally selected, and then we click create result in new ROI. We have to always remember to click it in new ROI, uh, because if we don't do that, our previous steps will be like the new file that will be created will be superimposed on the old file, and we'll lose all the previous steps. So to preserve our previous steps, we have to always click create result in new ROI, and it's better to name then and there so that we in future we don't have any problem in looking for the things that we have created. We'll select foreground like this, and then for background we'll click on background and select all the other area. In that case, we can also we can also increase like the diameter, and then we can select a larger area easily. Then we come to subtract. In this option, we can this is also present in edit tool. We come to combine and subtract, and then we have to select our selections, like the part that we want, the bigger part, from that what we want to subtract. So if like here I've selected bone CT, then I'll select mandible, and then I'll click create result in new ROI. That will help me create a maxilla. Like I'll rename it as maxilla, and that will help me create a maxilla. So I have two parts separated, my mandible and maxilla are separated like this. Similarly, we can also use unite to join two parts, but we don't need it here. So I've not shown it here, but it is like same. We have to select one part, the other part, like if you wanted to unite mandible and maxilla, so I'll select unite from that edit tool, and then I'll use mandible, then I'll here select maxilla, and then I'll select create result in unit, and it will combine both the parts. So isolate is the other option that is present in edit tool, and then for that is used it is used to remove isolated pixels, like some scattered pixels that are present in the DICOM that are difficult to remove because they are too small and you don't know at how many slices they are. You can just select your region of interest, like I've selected bone CT, just click on the region, whatever you want to keep, and then you have to just click the create the result in URL. It will automatically remove all the isolated pixels, and you'll be left with whatever you require. 3D interpolate is the other option see here in edit tool that is used to make changes at 3D level. So as we all know that DICOM is made of many slices. So it's not practically possible for us to work on each slice. So for that 3D interpolate is used. So it helps us to skip few slices, and this option automatically like selects the area in between, and at 3D level it just like combines whatever we have selected on one slice on the other slice through pixels and voxels. It's just work like that to create like so that we can skip few slices. So it helps in that. So we do 3D interpolate, so like the mandible is not missing from some slice or something like that. Then now that we have separated our mandible and maxilla and smoothed and done everything about it, we can export the STLs. For that we have this option in here, like this was thresholding, this was edit, then we have this export. We click on export, we select the bones what we want, like maxilla and mandible, and then we select STL, and then we always have to check that we have unselected this box of merge selection to single file, because if we don't uncheck this box, whatever we did throughout will be lost, because this will merge both the files and a one 3D image will be created. So we have, if you want mandible and maxilla to be two models, so we have to always see if this box is unchecked. Then we'll select our output directory where we want to save the file, and then we click here. You can also see these eye made near mandible and maxilla. These eyes are used for the visibility, like while we are working, like when we have created mandible and maxilla, we don't want to see the bone CT as a whole. We want to see them as a two separate parts. So we can hide the bone CT wala by this step, and mandible and maxilla can be open so that we only see mandible and maxilla and not the bone CT. Then there is also a option of saving the project. The project is saved as a .mcs file, and we can save it from the files drop down menu, or there is this option of save project. We can use that. The .mcs file can be directly transferred to Proplan from here only, or we can also open it in Proplan. Then we have also have options of undo or redo. Like if we think that we have done something wrong, we can always undo it and use these options for that. Then we come to Proplan CMF. Uh, this software gives us the options to, sorry. This software gives us options to use many tools like cephalometry, soft tissue stimulation, osteotomy, and then this has design tool in which we can also split, merge, and use it for other purposes. And then there's distraction, reconstruction with fibula, and orthognathics and splint design. These are the many things that this software can do for us. So let's begin with this software. First, I'll talk about osteotomy. Like in this case, we did not have like in this patient, we did not have the mandibles. It was all, the patient already came with like this to us. So before starting, we wanted to remove this part. So for that, like we can start with like osteotomy. To draw, the first step will be to draw a osteotomy plane. For that, we have these options: planar, V-shaped, Z-shaped, curved line, or surface. Whatever we want, we can choose from it. Like I've chosen planar here. Then we have to indicate 3 points. So we'll just select 2-3 points on this particular 3D model, and then the plane will be created. If I can show, yes. Like I have selected these 2 points. I hope you can see I've turned them into red points. So it will be green in the software, these points, and then I'll click 1 point over here, and when I'll like double, you have to double click when you have to complete the points or like the complete the plane. So when I'll double click on the third point, like somewhere here, the plane will be created. I hope you can see the plane. It's visible in all the 4 images. This green color thing is the plane. So the plane will be created, and then we can adjust the plane. Like when the plane is created, we feel no, the direction of the plane is not fine. We can just change it and we can adjust it. We can also, for adjusting it, we have these options of translate, rotate, and resize. We can translate it. We can rotate it. Like I have chosen rotate. So you are seeing these circles around the plane that are used to rotate it. Like wherever the midpoint of the circle is, that is our center of rotation. And around that, the plane will rotate. So when I'll like move my cursor on this circle like this, the plane will rotate clockwise. If I move it like this, it will rotate unclockwise. It's like that. We can also preset like the width here is 48 mm. So we can resize the osteotomy plane. If you want a thicker plane or a thinner plane, we can just change it here. Then the next step is performing the cut. After we have adjusted and we are satisfied with what we want, we perform the cut. And when the cut is performed, we'll have we'll see the mandible in 2 colors to show that yes, the cut has been performed. You can see that it is turns purple here and it is yellow here. So these are the 2 cuts that are created. Now here only I'll tell you how we can like move the cut. Like if you want this cut to move, for that we'll need it in orthognathic surgery, we can move this cut also. So for that, before that I'd like to tell that as I told in that also, that always rename the parts so that it is easy to find them. Because if it manually generates, if the software generates it, it will be like cut this, like this, cut, they'll like mention like that. But we can always just rename it for our own purposes, that this is mandible cut 2, okay, this is the part we don't want, or something like that. We can for that we can just see this eye. Here we'll click this eye option, and this option will come. Here we can rename it and click OK, then the name will be changed. So I was telling about the repositioning of cut sections. So for that, we'll just select a mandible. Like if we want to select mandible cut 2, I wanted to reposition this portion, so I've selected mandible cut 2, and then we'll select that whatever bone we want to cut, and then it will say show control for interactive translation. So we will click on that. Either we can just give a size limit here, like we want to move 2 mm or 1 mm, then we can write it here and just click left or right or whichever side we want to move. Or we can do that manually. For that, I'll show you. This is done like this. And to see whether we have selected the correct part, I'll just check it with the eye visibility button. So I've checked it here and seen if it's the correct part I've selected, and then show control translation, and then we can manually move it with the cursor. So that's how we reposition the cut portions. Now there's the second option of in the tools of mirroring. That is present in the general 3D operations of design tool. I've shown a long list where there was a design tool in that list, and that we select, we have general 3D operations. In that, this is the options we get, like mirror, merge, split, unite, intersect, subtract. We have already discussed subtract, unite, and all. So I'll discuss mirror here. Mirror is used, like we can, mirror is used to like, here I've used it to mirror the left side of the mandible because we wanted it for further guiding, as a guiding plane. So I've mirror for this, we'll just use the selection mirror over here. Then we'll select the plane in which respect we want the mirror to happen. So if we select the osteotomy plane, that was somewhere here, so the mirror will happen along this plane. So I have selected mid-sagittal plane. Here, see, I've selected mid-sagittal plane, so the mirror will happen in respect to this plane. So keep original objects has to be clicked so that we don't lose the previous things that we have already done. Then we'll select the plane, we'll select the bone, and then we'll click apply. So a mirror image will be created like this. But the question arises, why did we mirror the mandibles? So I mirrored the mandible because I wanted to do fibula reconstruction on this case. So I used the mirrored mandible as a guide to where I want to place my reconstruction parts. So for that, we come now I'll start with reconstruction of fibula. For that, we'll select this wizard from that menu of services, and there we select this ROI split this fibula from this menu. The fibula is also like created in the same manner that I created mandible in Mimics in Print, and then we brought that fibula still file here. So we have got these file, and then we just have to select the planes. Here we have only one plane because the whole mandible was missing, but usually there are two planes, one on the above and one the osteotomy plane on the below side. So we select those planes and then select points, 3 points like 1, 2, 3 I've selected here. You can select 2 or whatever you feel is correct. And then I've selected these points, and then I've clicked apply on the fibula, and then the software itself creates these cuts on the fibula, and it shows how long your single cut is and what is the distance between two cuts and from where you can like have these cuts. So this is how the software shows us that how we can like reconstruct the fibula on the mandible. And we can change these points whenever we want. We can change the cut parts also. We can like reposition those parts, like just select that part from the drop down list in reposition, and then we can do the reposition like we did for the osteotomy cuts. Then we come to cephalometry. Cephalometry in this software, it has certain analysis pre-feeded in it. So we just have to select analysis, like here I've selected McNamara, and then it will show you it will ask you to mark certain points. So when we see the, like it will ask you to mark point A. So we can mark it anywhere, either on the DICOM or on the 3D image. And it also tells where the point is, so that if someone doesn't know or someone cannot recall at the moment, like turat, so we can always check where the point is, and we can just mark it here. So it will ask you to mark all these points, and we have to mark them one by one. And then we'll finally click calculate, and it will automatically show us the analysis. There's not, we just have to mark the points. In the next we come to orthokinetic planning. For orthokinetic planning, we have to create a composite model first. So for that, we open the orthokinetic wizard from the services part, and two windows will appear. These two windows are there because now we have to superimpose a cast on the maxilla for a better maxillary or occlusal area, so that the splint that is created later is has better occlusal surfaces. So we create a composite model by here. From this drop down menu, we have to, it says select maxilla, so we'll select maxilla here from the maxillary bone, and then we select the STL of a maxillary cast. We import it from the file drop down menu, and then we select the maxillary cast, and those two like I have selected here the maxilla, and then we'll select the maxillary cast, and then a then it will ask you to register. Register can happen by 3-point registration or by manual registration. It's the registration here refers to like when you go to register, when you'll come to that point, it will change into 3 windows. Like one window will show you your maxilla, one will show you your cast, and the third will show your composite model. So we'll have to select, it asks us to indicate 3 corresponding points. So we'll select one here, then the corresponding point on the cast, then we'll select second point, the corresponding point on the cast. Like that, we'll select 3 points. We can add points if you want. It's not like we have to select only 3 points. For better accuracy, we can take more points. And then we'll click next, and this composite model will be created. Then after that, once we have like created this composite model, we can move on to the osteotomy part of the planning. So for that, it has these pre-cell plans of Leafort 1, 2, 3, BSSO, and genioplasty. So here I've selected Leafort 1. Once I select Leafort 1, then I'll have to select the like sorry. Then I have to select the type what we want. First I'll select the osteotomy type, then I'll select the bone. I'll selected the maxilla here, and then it will ask me to indicate 4 points. It will also show me the points from where I should indicate, and then I'll like create 1, 2. I've like created 2 points over here, 1 and 2, if you can appreciate. So after this, we can, after the 4 points will be created, it will create a osteotomy plane. We can adjust this osteotomy plane like we did earlier by translate, rotate, or resizing the plane. And then we can finally click next and have the osteotomy cut. As you can see, this is a composite model as it has the cast superimposed on it. So we'll have a Leafort cut like this. Similarly, we can do it in the mandible, and then I'll show how we can like reposition the mandible. Though this is not a BSSO cut, but I'll show how we can reposition a mandible. So from the reposition, after performing the osteotomy, we can go to the reposition wizard, and then we select whatever we want to move. Like here I've selected the original mandible. So similarly, I've checked it that whether I've selected the right thing that I want to move, and then I'll activate the controls for rotation or translation, whatever I want, and then I can move it manually or by giving a minimum size like 1 mm or 2 mm or whatever movement I want. Then we come to soft tissue simulation. This is basically sorry, this is like my favorite part because here we get to see how changes have occurred, how our planning went, and how the changes will appear in a patient. So here we'll just calculate, we'll just select soft tissue simulation. We select the bone parts, and then we'll calculate the new simulation. Once the simulation is created, we'll just play it. When we play it, we'll able to see. If you can notice in the left lower left corner, there's a movement there. If we can see, I'll show a close-up. Sorry, I'll show the close-up on video. So that's how it shows us how our planning has went and how the soft tissue will be seen. So that's it. Thank you.
तो बिना मैम इसीलिए हम लोग की नेगेटिव आई है वहाँ तो रंजीत पाटिल लिखी ऊपर रात पार्टी वंदना
हाँ. So any questions for Dr. Kananika? Kananika, you spoke well.
Thank you, ma'am. Thank you, ma'am.
Uh, Abdul. So that's it. We have come to the but tomorrow now we have tomorrow we have a lecture by the company people on haptic freeform. So how the same thing can be done using haptic freeform geomagic, and tomorrow we'll be looking at geomagic with freeform software. And then day after tomorrow we have IIT Kanpur professor speaking on FEA analysis. So that's for the next 2 days. So thank you. And we have extended the date. Archana, Shuchi, and the other people who have not yet submitted their project proposal may submit by 15th of September, so that we may plan them and proceed by the end of this course. So thank you. See you tomorrow. Same time, same web link. So this link is the same for the entire week.